Hello, my favorite Mishler Math students. Welcome back to Mishler Math, exciting lessons in geometry. This is this little thing I made here in red. This is called a polyhedron. Okay, a polyhedron is a very simple definition of a polyhedron. Okay, and it's a bunch of polygons that are put together to make a three-dimensional figure. Now, as you can see here, I got a rectangle along this side, I got a rectangle here, got a rectangle on the back side and a rectangle on the bottom, and on each end, A, B, C, D, and E, F, G, H, I have a square. So I have a square on each end and rectangles. So I put a bunch of these polygons together to make a polyhedron. It's a three-dimensional figure. Now, polyhedra, this is talking about when you get more than one polyhedron. For example, if I drew another one of these, which I'm not going to do because it'll take too long, but if we had two or more of them, we would have polyhedra. So this is just a plural of polyhedron. Okay? Now, there's some parts of this that you need to understand. Okay? For example, G or B, let's say B, is a vertex. Okay? Now, what are some of the other vertexes on here? Well, C is a vertex. Remember, a vertex is a point, just like the vertex of an angle is a point, or the vertex of a triangle is a point. A vertex of a polyhedron is a point. So, as you can see here, how many vertices do we have? A, B, C, D, E, F, G, H. 1, 2, 3, 4, 5, 6, 7, 8 vertexes on this particular polyhedron. Okay, then we have FA. Okay, FA, segment FA, that's called, oops, I didn't mean to say face, I meant to say edge. FA is an edge. Okay, so what you see right here, FA, okay, that's an edge. Okay, an edge is simply where two planes meet, and they form a line or a segment in this case. That segment is called an edge. So we have a vertex, we have an edge, and then we have a face. Now, this is not the kind of face that I'm talking about. Neither is this. Okay, the face that I'm talking about is, like for example right here, if you see there's a face, it's bounded by F, A, D, and E. Okay, fade, that's a good one. So, but remember, I don't need 4 letters to identify a plane. It only takes 3 letters to identify a plane. So this is a new fad. Anyway, so this is a face, okay? A face is just one side or one polygon for a polyhedron. And those are the main parts. Now, there are different kinds of polyhedra, okay? We have cube is the most common type, and a cube looks like this. Now, of course, this is that website again I told you about, and you see you can move this thing around. Isn't that cool? So this is a cube. As you can see here, here's a face. Okay, here's another face, or excuse me, here's an edge, here's a face, and I'm going to make an edge red. That red thing there is, oops, that's not what I wanted. That red thing there is an edge. The blue thing is a face. Okay, I can make the vertex green. Okay, so there's that vertex, which is green, and it's got a big circle around it. I don't know why that big circle is there, but I guess to point out that this is a green vertex. Anyway, so that's what we have, is we have a cube. There are other ones. There's a tetrahedron. That sounds pretty interesting, doesn't it? I don't like the word tetrahedron. I prefer to call this a triangular pyramid, or a triangular based pyramid. Now this is a regular pyramid, which is a regular polyhedron, which means that all sides are congruent polygons. Okay, and that's what a cube is a regular polyhedra or polyhedron, because all four sides of the cube are congruent. They're congruent polygons. Octahedron. You can see here, this is a regular polyhedra, and as you can see, octa comes from the fact that there's 8 sides. Actually, if you take one square-based pyramid, you see there on the top, and another square-based pyramid, so you got 2 square-based pyramids there. But wait, it gets interesting. Dodecahedron. Isn't that neat? It's getting to look a little bit like a soccer ball, isn't it? That's a dodecahedron. And icosahedron, yeah, okay, you go ahead and figure that one out. And go ahead and count the sides if you'd like, but I'm not going to. And my own net. And you can create your own net. Now the neat thing about this, watch what happens when I do the cube and I say do the net. Here's a solid. Isn't that cool? That's called a net. That's why I take this thing apart, okay, and put it back together. Now let's take a look at the octahedron and do the net with that. Isn't that cool? And that turns it into a net is simply when you take all the polygons and lay them down flat. And by the way, this net, that net is pretty handy when you're trying to figure out the total surface area of that critter. So much fun with that. Anyway, those are the things we're going to talk about. Let's see. Parallel lines and planes. Aha, we're not there yet, but give me a second. Here we go. Parallel lines and planes, okay? Parallel lines or edges, okay? Let's look at which lines are parallel. GB, that's supposed to be a G. GB is parallel to FA. What else is parallel? AB is parallel to DC. You notice when I'm talking about parallel, I'm talking about, I use a line over top of there, because I'm not talking about the length of these segments. I'm talking about the naming the segments and saying they're parallel to one another. What about, say, GB and say EF? What's the relationship between GB up here and EF over here? Now EF, as you can see, goes like this, okay? GB goes like this. Now, are those two anywhere near each other? Are they ever going to intersect? The answer, of course, is no, because EF goes up and down here, GB goes this way, and so they will never intersect. Now, when we're talking about a plane, we said if two lines are parallel, that means that they never intersect. Do you think these two lines are parallel? No, of course not. So they call those skew. Skew lines, okay? Skew lines means that they're not parallel, which means that they're not in the same plane, but they will never intersect, okay? So what does it mean when we say a line is perpendicular to a plane? For example, suppose I set a line here that, and I'm going to make this in blue, okay? And I'm going to make a blue line here that, and it wiggled a little bit, but and this is kind of like in the bottom, okay? Alright, so this goes through the plane FGB, which is on top, okay? It passes through plane FGB. At this point, we're going to call this W, okay? So it passes through this plane at point W. Now, what would happen if I drew a straight line on this plane passing through W, okay? So I put a straight line here passing through W. Now, this line, and I better identify this, X, Y, we'll call it XY. XY is parallel to plane FGB, okay? Because if I put this segment through here, or this line through here, and it passes through point W, sorry, that doesn't look good there, passes through point W, well, then that's going to be perpendicular to XY. So this line would be perpendicular to XY, and the line is in the plane FGB. Now what if I put another line through W, and that line went like this, and that line was also contained in plane FGB? Well, that line would also be perpendicular to XY. And so what we have is a rule that if a line is perpendicular to a plane, then that line is perpendicular to every line passing through that point in the plane. So no matter, now the reason we say that is because what happened if I put a line here that goes through the plane this way, and it passes, and it was perpendicular to this line? Well, it wouldn't be perpendicular to this other line, so it couldn't be perpendicular to the plane. So in order for XY to be perpendicular to plane FGB, it has to be perpendicular to every line that passes through point W, where it passes through the plane. Now, if that doesn't make sense to you, that's okay. We'll discuss this further in class. All right? So, what about parallel to a plane? Suppose I put a line out here, and it's time to make a pink line. I think so. So this line is out here somewhere, and it's pink, and it's going to be parallel to the plane FGB. And we'll call this LM, okay? So LM is, oops, did I put, oh my goodness, look what I did. Nobody caught me on that. Next time, stop me. I said XY was parallel. I used the parallel sign. I was supposed to use the perpendicular. Sorry if that confused you. XY is perpendicular to plane FGB. I am so sorry for that. Now, let's get back to the parallel. LM is parallel to plane FGB. Okay? And how do I know it's parallel to FGB? Because LM is parallel to GB. Okay? Look, here's GB. LM is parallel to GB. LM, go down here, LM is also parallel to FA. Okay? So the reason it's parallel to the plane is because it's parallel to infinite number of lines in the plane. Okay? So that's enough of that. Now there's one more thing that I need to show you on this thing, and that's why I had the book open a moment ago, because I'll show you this from the book. This is a dihedral angle, okay? Dihedral angle. A dihedral angle is the figure formed by two half planes with a common edge. Half plane simply means I put a line through a plane and I take half of it and I get rid of the other half. So I got two half planes that come together here, just kind of like when we've got two half planes that come together here, okay? When you got two half planes that come together at BC, that BC or FA, these are called edges, okay? So, take a look here. We got half planes that come together. This is the edge, the line or segment formed when two half planes come together. Okay? And For some reason, I've got the beginning of something I don't want there. So ignore this thing over here because my computer's acting goofy again. Or I could just close this. That's what I want to do, close that silly thing. All right, dihedral angle is right here. These are your faces. The dihedral angle is the angle formed by these two planes. So how do you measure? Like for example, if you look at the dihedral angle between the side ABF. ABF is that side in the back, and ABC is a side on the top. So what's the dihedral angle? Well, that's the angle EAD. It's formed by these two planes coming together. So how do you measure a dihedral angle? Look at what they're doing here. Okay, they draw a straight line on this patty paper, and then you put point A over top of point C. Okay, and that angle, okay, this angle formed by those two sides of that plane coming together, that's the dihedral angle. And again, this is kind of hard to understand if you're not used to thinking in 3 dimensions. And that's okay, because it'll help you. You know, we'll do some of this stuff in class, and we'll do a little bit more of this so you can help understand some more. So that's all I got for you today. Thank you so much. Have a great day.